Good afternoon, good evening, or good morning, depending on the time zone you connect to StruSoft's Archicad to FEM-Design webinar. My name is Ákos Rektoris, and I'm a product manager at StruSoft, and I'm sitting in the FEM-Design headquarters in Budapest. Before I get into the topic, allow me to tell you why I'm the presenter of this webinar. After completing my university studies, I worked 9 years at the development of FEM-Design. Then I was one of the product managers of Archicad at Graphisoft, and for 12 years. I was responsible for interoperability themed developments such as IFC and BCF, and in addition, I was responsible for the new Archicad 24 developments, such as the new analytical model project or the engineer-to-engineer collaboration. Currently, starting in September, I'm working for FEM-Design again, and on the same topics. For example, how to process architectural and engineering models and data arriving from Archicad. Well, let's start our topic for today, which I have divided into the following sections. Introduction of Graphisoft's new concept about the so-called single model-based collaboration between different disciplines. Live presentation about the analysis model generation and export within Archicad, and live presentation about the data processing in FEM-Design. If you have any questions during the presentation, you can write them in the question palette of the GoToWebinar application or send them to me by mail. I will reply to all of them by email. This year, in July, Graphisoft released Archicad version 24, which delivers 4 years of under-the-hood development to modernize model collaboration between design disciplines. For the design phase, when there are a lot of iteration work between the disciplines, Archicad 24 and BIM Cloud offer a common workplace for real-time collaboration among project team members. Architects, structural engineers, and MEP engineers can work together on one common model in real time with protection for the different roles and responsibilities. When they set the construction elements and their function together, Archicad creates the analysis member representation of the load-bearing elements under the control of the structural engineer team member. This analysis model becomes the parametric input for an analysis software to create its own native model without data losses of any conversion. As a side note, for the detailing phase, Graphisoft still promotes the so-called reference model concept in the name of the Open BIM approach. That means Archicad can federate IFC models stored on BIM Cloud within the project. If we go back to the analysis model part, there comes the opportunity to connect to Graphisoft's new ecosystem with FEM-Design as a structural model analyzer, as a steel, reinforced concrete, or timber designer. As mentioned before, the analysis model is the common language between the structural BIM modeler, Archicad, and the analysis software, FEM-Design. There are 2 open source file formats that can be used for analysis model sharing. The so-called IFC special model view set, we call it structure analysis view, and an Excel-based new format called SAF, structural analysis format. Both are optimized for storing analysis model components, such as beam, column, wall, slab members, structural supports and connections, structural profiles, and materials. But there are 2 major differences. Thanks to SAF's Excel format, engineers who especially love Excel immediately and easily understand the file content, easily check its correctness, easily edit them within Excel if necessary. They can also create macros or functions to manipulate or to use Excel data for other reasons, for custom calculations. You may also read an IFC file, for example, in a text editor, but you should understand the hierarchy and the relation between the members, the file rows. You are not able to see the same type items like materials, profiles, supports, nodes, and so on, together listed on one page. As opposite, in SCF, you can see the different item types in different worksheets. SCF schema, its goals and requirements are up to date. Several leader analysis and modeler software developers, including StruSoft and Graphisoft, together continuously develop and improve and maintain the schema according to the latest trends and requirements. IFC analytical view schema was developed in 2006 and its maintenance was stopped around 2010. As I said, the SAF schema is open. Its description is available on the following public site. You can find it here. And you can easily understand the meaning of the column headers or items of this file because you can see here description, examples, and so on. Now let's start the live demo about the collaboration workflow between Archicad and FEM-Design. I will use a Graphisoft project for the demo. And let's see it live. Here you see the initial architecture. And thanks to the layer system or element classification, you can easily filter for the building model. And maybe you can show the building model or only the construction elements without furnishing. If you have classification for the load-bearing elements, you can easily filter for them with one click. So you can use the partial structure display. We call it core of load-bearing elements only. I show you a section view of this model. And here you see that, for example, the slab has a composite structure. If I check the skins of the composite structure, there is one core skin of this composite called reinforced concrete structural. Here you see the core. And if I show now with the partial structure display the core of load-bearing elements only, you can see only this core part. This is important for the analysis. In Archicad, the software creates the analytical model inside the core parts. It's the same for the walls because it's also a composite element. You can easily check its material. And if now with one click I show you the analysis model, you can see that the members are generated only in the core, by default in the center of gravity of the elements. I can hide the physical body. You can see much better the analysis members. You can see here 2D members for slabs, walls, roof elements, and 1D members for columns, beams, trusses, and so on. Let's see how Archicad generates the analytical model. Here you see an example. There is a column and a beam connected to each other, and by default, these elements are not adjusted. As mentioned before, the default position of the analytical members are in the center of gravity of the elements. The user can define rules, or Graphisoft also suggests adjusted tools in the package by default. You can define how these elements should be connected. What is very important, and it's a must, that the analytical model must be continuous, because one element transfers the load to another. And it's important input for the analysis application that the finite element and the calculation should be run on a continuous model. Here you see an example that the user creates an offset for the beam. This is the first rule. Then just stretch the column to the beam, and it's cut back the beam to the common intersection of the two elements. You may ask why we need this offset. Because it's very important, you would like to consider the neighboring elements. So here you see a neighboring connection with major elements connected to each other. That is why we need to offset this beam element and then continue with the stretch, the cutback function. So the user can create global and local rules, and based on this, they can fulfill the continuity requirement. I just show you the dialog. Here you can define the adjusters. And for example, here are the global rules, which are valid for a tool, for example, for a slab tool. So there is an offset adjustment for elements created by the slab tool. Or you can define local rules defined by criteria. For example, they can use classification to define different local adjustments. For example, adjust the footing classified elements to the slab elements. You can also set rules how the software handling openings and so on. Finally, here you see the analysis model I showed you before. As you saw that in Archicad, you can also create supports to support the whole structure. Here is a special command for this, structural support tool. And you can also define the end releases of the members. So here you see bar elements, and if I turn on the visualization of end releases, here you see that for beams, one end has fixed connection and another end has so-called hinged connection. So all rotation components are allowed. If we are ready with the analysis model, we can export this model to an analysis software. For this, you need to do so-called profile and material mapping. You should define this mapping optimized for the receiver application. Some analysis application has their own mapping system, but I think it's much better to do it in a modeler. For that purpose, Graphisoft implements so-called SAF translators. And here you can set settings for import and export. And here you see, for example, the material mapping. As you see, by default, it's empty, or it can be defined by the default Archicad template. But now I would like to focus on this project and add some materials. For example, there was the slab part. It was reinforced concrete structural. There was another material for the walls. It has this concrete material. Also, there were steel elements. It has this steel structural material and so on. Here you see that the list for the mapping is empty, or there is only one object. Here you need the FEM-Design named materials. How you can get these materials? There is a so-called SAF material importer where you can import, for example, all materials defined by default in FEM-Design or defined by a FEM-Design user. Just click open, and as you see, all concrete materials, all steel, timber materials are now available in FEM-Design naming. So then, if I go to reinforced concrete, I can choose that for reinforced concrete, I would like to set it for a FEM-Design material with this concrete quality. Then I choose another material for the other Archicad material. Of course, in Archicad, you can create also well-defined concrete and steel quality, but in this project, the architect together with the structural engineer just define general materials. And for steel, instead of concrete, I can choose this steel quantity. There is a so-called Jolly Joker material. That means that all other materials which are assigned to the analysis model but not mapped here will be mapped with the Jolly Joker material. For example, I use a very weak concrete for it because we need investigation of these materials. Let's go to the profiles. With one click, I can import all profiles used in the project for the load-bearing elements. In this project, only one steel profile was used, and now I would like to map it. For that reason, I can import first the same. Here you see that the SCF cross-section list is empty. So now I import all profiles available in FEM-Design or in a FEM-Design project from the catalog. And here you see thousands of profiles available now. Then I can go back, and here you see that I would like to use name mapping. That means that this steel profile should be mapped with the FEM-Design available profile. Then I search for this element, and here you see the same name, but in different written formula. Okay, I'm ready with the material and profile mapping. There are some other mappings for the export. For example, by default, Archicad uses a special local coordinate system for positioning the cross-sections for 1D members, so for columns and beams. FEM-Design uses a so-called general local coordinate system. So here you can use here you should set the local coordinated system used by the receiver application. So now we use FEM-Design, so we use this setting. And the last settings at the export is about the curved walls. You know that the major structural analysis application doesn't support curved walls. They use polygonal, so-called straight segments for the curve parts. It's true for FEM-Design also. So now I use the so-called segmentation settings. And then I am ready for the export. If I collaborate with FEM-Design in the further projects, then I can save this as a translator, and I can use it, or I can add it to an Archicad template, and I can use these settings for all. Of course, you can define more detailed material mapping. Now I mapped only the used materials and cross-sections. Okay. Then when I'm ready, now I can start the export. I can export the whole analytical model, the entire analytical model, or I can export only some parts of it. So for example, or columns, or beams, and nothing else. So here you see the frame structure. Or I can select one frame standing, and I can export it. So if I go to export settings, so save as, here you see that there are three options. Selected elements means the elements I select in the model view, or the current model view. If I choose visible elements, I export all elements visible in the current view. If I choose entire project, I export the entire analytical model. Now I would like to export the entire analytical model. And I give a name, for example, Archicad analytical model. Then save it. As you see, it's very fast. Then I can check, it's not a must, but I can check the analytical model file, the Excel file here in an Excel, or in Windows you can use this preview mode. And here you see that there are different sheets in the Excel file. So there is one page for the project info. There's another one for the model info. Here you see the local system, what we use, and you set for the export. Here you see the materials. As you remember, we map the three materials, one steel and two concrete. Here you can see the one profile and use the FEM-Design naming because I use that for mapping. I really like this Excel format because if something wrong with the mapping, if I make mistake or I'm lazy and I forget to do correct mapping, I can easily override here the names and so on. Here you see the nodes, the endpoints of the corner points of the members. Here you see the curve members represented with beam and columns and other elements. Here you see the surface elements represented by the slabs and walls and roof elements in Archicad. Here you see the openings, for example, the door openings in the walls. And here you see the edge connection, so the linear support under the walls. Here you see the surface connection, so the surface support added to the footing slabs. And the last sheet here contains the end releases. Remember, there were beams with different settings for the end and start ends. And here you can see the hinge connections. So the rotation components are free, they are allowed. Okay, now then I can go to FEM-Design. I just use the open command. I select the file format, SAF, and here you see the file. I export it from Archicad, and with one click, a dialog welcome me. I can choose a standard for the calculation and the design. I use the general Eurocode now, and voila! Within 2 seconds or less, here you see the analytical model defined in Archicad without any data losses. So if I select, for example, here you see the beam, here you see the profile, and the material is correct. Here you see the slab, the material, and the thickness is correct. So it's the core thickness, not the whole slab thickness. As I mentioned before, it was a composite. Here you see a wall with the same material and the thickness, and so on. Here you see the supports defined in Archicad. And let's see the end releases. Here you see the hinge connection, and the other point there is no symbol, that means it's a rigid end, and so on. So the model is here. I may run calculation for this, but before I do this, I always check the model that it's continuous or not. In Archicad, there are also checking tools to check the continuity of the model or overlaps and so on. But you can find these options here in FEM-Design also. I always run the finite element mesh generation to see that the elements are connected and there is no problem with it. And here you see it's very fast, and it sends us one warning. It's just a warning, it's not an error, so there is not a real problem, but a warning that there are two small finite elements. Now I investigate it, and if I zoom in, here you see that there is very, very small parts with very, very small finite elements. What can I do? I can solve it in Archicad, or I'm here in the FEM-Design, so I go back to structure, and we have this correct model function. I select all elements, and I can run checkings. For example, I start merge region lines because there are small regions here. Just start it, and here you see that the program immediately finds this warning part. I fix all these issues, and if I apply it here, you see that the program solves these very small regions. Now I go back to finite element mesh and rerun the element generation, and if the program doesn't send us a warning, that means that our model is correct. Here you see, I can show it in shade mode. Very nice finite element mesh on this structure. Okay, now I would like to run a very fast analysis for this. For that, purpose, I create one load. I call it dead load, so the self-weight of the structure, and I just say that, okay, this contains the dead load, press OK, and now I can go to analysis and run calculation for this load case. It's very fast. Of course, you can run calculation for only some parts of the building. So for example, if you export only the frame structure or one standing, of course it's more faster because of less elements, but I hope you can run a very fast calculation for this. Now we are close to the end. It calculates the internal forces, and here you see around half minute we got a result. And you remember there was, I don't know, 2 seconds when I import the model. So within 1 minute from the import, you got an analysis result for the whole project. I think it's amazing. And now I can show results. For example, I show you the displacement in color palette mode, but of course you can show the deform shape together with it. Here you are. If you don't like the original position of the elements, FEM-Design has a layer system similar to Archicad, so I can hide, for example, the elements, just focus on the results. And here you see, I can run an animation to see much better how the whole structure deformed for the dead load. And if I stop this animation, I can also show you maximum values. For example, I would like to search for the maximum displacement. With one click, I can do that. And here you see that 15 millimeter is the maximum displacement for this whole structure for the dead load. When I'm ready with the analysis, I can go to documentation, and I can create a template for the documentation. I already did it for this demo. And the program automatically generates results within, I don't know, 10 seconds. Here you see. And then you can go through the pages. Here you see that there is a cover page. Then you can see an image about the structure. If you don't like the display settings of one image, I really like it that they are live images. So I can click on it, I can zoom in it, I can do shading for the elements, I can rotate the model if I don't like the image. And when I click outside, this will be fixed for the documentation. Then I can show you here, you see that there is only one load, the dead load. There is a finite element. It's much better to show it in shaded mode, or you can zoom in a part of it, as mentioned before. Here is the deformation. You can also use this shading mode. You can add values by clicking on the image if you like. So here you see the displacement. The reaction forces, maybe it's much better to rotate the document here because of the size of the image, and so on. And with another click, with an extra click, you can save it as a PDF or you can save it as a Word document. One of my colleagues created a whole analysis for this sample project. He defined more loads. Here you see the dead load, the live load, the wind load, and so on. And also created load combinations, or load combinations required by Eurocode. And then he ran calculation analysis, for example, steel design. And here you see the deformation. The maximum value is doubled than the self-weight. And here you see that I can check the utilization of the steel element. And here you see that there are problems with some columns and beams. They are more than 100% utilization. That's not good. So in that case, you can modify the size of the element. So for example, the profile, or give more strength material. You can send this analysis result back to Archicad, for example, in PDF. So, and you can place the FEM-Design PDF inside Archicad as a document, and you can see that it's really nice quality of the elements. So you can easily check. Here you see the loads defined by colleague and the results with the maximum displacement. So that was my presentation, and I hope you really enjoy it. And as mentioned before, please write your questions in the webinar question tab. We will close the meeting at 2 p.m., so we still open it, or please send it to me as an email and I will answer for them. Thank you very much for your attention. Goodbye.